Hello, students. We're going to review quickly the 6 questions for the program function and purpose quiz. I'm going to try to move quickly through it and try to explain some things. I know some of this is going to be very new to you, and I'm going to direct you to use the reference sheet that explains some of the notation and syntax here. So it says question one, and again, I'm going to maybe take a little more time to explain this. This is the assignment. So as the assignment operator, basically it says assign value to a variable or a holding place called result. So basically, it makes result equal to 2. That's what that means, that first little block. Then the second block, it says repeat 3 times. So it means repeat everything in that gray block 3 times. So what it's going to do is say assign a value of the operation on the right. So there's an operation going on the right hand side, and it's going to solve that first and then assign the result to the variable on the left. So the assignment operator, the order of operations is to compute whatever's on the right hand side first, and then the result or the result of that operation is assigned to the variable on the left. In this case, the variable is called the result. So this might be kind of awkward, but this is very common in programming. So basically, it's taking whatever the value is of that variable, it's going to multiply it by 5, and then assign it back to itself. So, and it's going to do that 3 times. And then at the end, it's going to just display it. So basically, what it's going to do is going to start with result being a value of 2, and then it's going to multiply that by 5, and then it's going to, so there'll be 10, and then it's going to take that and multiply that result by 5, so then we're going to have 50, and then it's going to take that and multiply that result by 5, and then that's going to be 250. uh, so we are multiplying by 5 3 times, and the first number was 2. So let's see which one of these fits that best. And it can be kind of tricky. Sometimes, you can have a scratch paper that can kind of help figure this out. So which of the following operations best describes the behavior of the code segment? So they all have this 2 times, right? 2 times and then something. Well, it's not 2 times 5 times 3, because I'm not multiplying 5 3 by 3. I'm multiplying by 5 3 times. So right away, it's not going to be these first two. So A and B can't be correct. And then the second two, C and D options, and again, I'm not sure if they're coming in the same order for you, but the two options that say that it displays the value of 2 times 5 to the power of 3. That part is correct. That part is correct, but let's see where they are different. By initializing the result to 2, so that's correct, and then multiplying the result by 3 a total of 5 times, that is not true. It multiplies the result by 5 a total of 3 times. So if in my order here, the correct answer is D. It's 2 times 5 to the power of 3 by initializing the result to 2 and then multiplying it by 5 a total of 3 times. So that's that 5 times 5 times 5, or 5 to the power of 3. So we're going to move on to the next question. That was hopefully clear. Again, some complex syntax here, so I'm going to take some time to explain it. So we have behavior of mystery procedure with an if statement. So we have not studied much of this or any of it yet, so I understand if this is confusing, but hopefully it can also be somewhat intuitive, and it gives you an opportunity to look ahead to some of these things, such as conditional operations. So we have in the following procedure, assume that parameter x is an integer. So I'm going to say that the parameter x is an integer. So it says we have this big box, it's called a procedure, and it's called mystery, and it's going to receive a value into it, and it's going to be labeled x. So this big box is kind of like a function, is another name for it, or a method or a procedure. So it's going to do some stuff, and the name of it is mystery, and it's going to have an input. Like it can work with different values, and whatever value we put in it, that's what we call the parameter, and in this case, it's labeled x. So what's going to happen with x? Well, first, we're going to check, is x less than 0? So this little oval here is evaluating whether x is less than 0. And then it's going to take the result of that operation and assign it to y. Okay, so X can be either less than 0 or not. So the answer is either it's true or false. So there's only two options. X is either greater than 0 or it's not. And then the result of that is going to be assigned to Y. And then if Y, so Y can be true or false. So then when it says here, if Y, display Y. So this if Y means that this little piece is only going to happen if Y is true. And it's going to just display true. So what that means that if X is not less than 0, so if it's 0 or greater, it just won't say anything. But if it is less than 0, it's going to display what? Well, being that X is less than 0, if that is true, Y is true, not the actual number, but true. And if Y is true, then it's just going to display true. So let's see which one of these makes sense. Um, if displaying it displays nothing if X is negative. No, because it's if X is negative, then it's less than 0. So if it's less than 0 or negative, it's going to display true. So this is not correct. It displays nothing if X is negative. So again, that's not correct. It displays true if X is negative and nothing otherwise. So it's C. Because again, if X is 0 or above, then it just nothing will happen. This will be false, Y will be false, and then this part doesn't happen because if false, this won't happen. So the answer here is C. It displays true if X is negative, otherwise it doesn't do anything. All right, I'm going to go to third question. A user who is organizing a meal with a group selects all the members of the group from the user's contact list. Um, the application then recommends. I'm sorry, I skipped the top part. Okay, I see. So Dine Out Helper is a mobile application that people can use to select restaurant for a group meal. Each user creates a profile with a unique name and a list of food allergies or dietary restrictions. Each user can then build a contact list of other users on the app. So that means that each user, you know their food allergies and dietary restrictions. A user who is organizing a meal with a group selects all the members of the group from the user's contact list. So again, you would know each of their food allergies and dietary restrictions. The application then recommends one or more nearby restaurants based on whether the restaurant can accommodate all of the group members' allergies and dietary restrictions. Suppose that Alejandra is using Dine Out Helper to organize a meal with Brandon and Cynthia. Which of the following data are needed for Dine Out to recommend a restaurant for the group? Okay, so we need so there's we picking a combination of these three options. Option one, each group member's list of food allergy or dietary restrictions. So we do need that. Alejandra's geographic location. Well, we need that. We already know that. So, but so hang on. Let me see. Which of the following data are needed for the dine? Okay, so which ones does the app need? So we do need the food allergies and dietary restrictions. So we need that. Alejandra's geographic location. So we do need that. That is something we need. It's not named, but okay, so that makes sense. We need that because how would you know we don't want recommendations like 1,000 miles away. Usernames of the people on Brandon's and Cynthia's contact list. We don't need that at all for this. If Alejandra is making it, she just needs their names. So what we don't need is three, but we do need one and two, and that looks like option A. So for me, it's option A, but basically it's whichever option says one and two only. We don't need three. Okay, and then the same restaurant, same situation, but the different is question. The options are a little different here. So, which of the following data is not provided by Alejandra, but is necessary for Dine Out Helper to recommend the restaurant for the group? So, okay. Brandon's contact list is not necessary, so we don't need that. Information about which restaurants Brandon and Cynthia have visited in the past. That is not necessary. It might be helpful, but it is not necessary. So we don't need the prior history in this context. information, and then option 3 is information about which food allergies and dietary restrictions can be accommodated at different restaurants near Alejandra. Um, we do need that, right? So we do need, so like for me to recommend which restaurants would fit, I would need to know what restaurants offer. So the 3 here is the only one that works. And for me, that is option B. So again, whichever option for you, if they're scrambled out of order, which I sometimes do, I don't remember if I set that up, it's the option 3 on this question. Or for me, letter B, but it's the only the third one here fits. All right, let me see if I can get this quickly. Oh, shoot, this one is pretty quick, pretty big. So I'll try to go through it pretty quickly. A student wrote the following code segment, which displays true if the my list contains any duplicate values and displays false otherwise. Okay, so this one maybe I should have left for later, but some of you may have figured it out. It's it has couple nested loops, conditional statements. So there's a lot going on here, and it might help if you have a piece of paper. We're going to try to go through it quickly, and then if I need to explain it individually, I can. Um, so my list contains any duplicate. So it's going to return true if the my list contains any duplicate values and displays false otherwise. The question, what's going to be the question? The code segment compares pairs of list elements. Setting contains duplicates to true if any two elements are found to be equal in value. Which of the following best describes the behavior of how pairs of elements are compared? Okay, so let's see if I can kind of describe what's going on here. So we're going to say contains duplicates. So basically what this means, uh, it's gonna check. So there's a list, my list, and we just want to see if it has any duplicate values, and if it doesn't, it's false. So what we're going to do is we're going to assume that there are no duplicates, and then we're going to look to see if there are any duplicates. And sometimes in coding, there's these uh, ways that are easier to approach a problem. So in this case, what we're looking for is we set up the default state. Excuse me. The default state is that what we're looking for doesn't exist there, and then we'll look to see if it does exist. So we're looking for duplicates. We're going to assume that there isn't any. So this top part, the first line says assign false to contains duplicates. That just means we're assuming there aren't any duplicates. I'm going to start a counter j at 1, and that's going to basically check each element of that list one at a time. So then it says repeat until j is greater than length of that list minus 1. So the minus 1 is because we're looking for duplicates. So basically, you just want to go to the element before last one. So this big loop here, this first loop, the outer box with counter j, is going to go through a list of numbers, looking at each number in order one by one. Okay, so that j counter is just going to go from the first element, from the index value 1, and it's going to go up to however long the list is minus 1. So it's going to stop short of the last element with this minus 1, because this inner loop is going to look to see if there's any of those, if there's a duplicate of that number in the rest of the list. So then this white box inside the bigger repeat loop starts with a new counter k, and it sets it up to be the next element in order from j. So it takes the counter j, that's the outer loop, and adds 1 to it. So the outer loop is just looking at the list of numbers, taking one at a time and considering. So it's going to look at the first number and then check the entire rest of the list past that to the end to see if that number shows up again. And then it's going to move to the next one and check the entire rest of the list to see if that number shows up again, and so on and so forth. So this minus this j plus 1 here is basically because we start looking at the next element and on to the end. So then basically this second inner repeat loop basically goes like, okay, well, we're going to k will go to the end of the list. So as long as until k is greater than the length of the list, it's going to keep going. And what it's doing is just checking to see if the value at location or index j is equal to the value at location or index k. Now, if it is, if they are the same, then we just say contains duplicates is true. Um, and we move on k plus 1 and j plus 1. So we basically move to the next place in the loop. Um, so, and then in the end, we just display. This is not the most efficient loop, and I hope I kind of explained it sufficiently enough. So let's see if we can describe it. The code segment iterates through my list, comparing each element to all other elements in the list. That is not quite true because it doesn't compare them to all of them. It compares them only to the ones that come after it. The code segment iterates through my list, comparing each element to all subsequent elements in the list. That's the correct one. So basically, it's going to go iterating, or basically taking one at a time until it goes through all of them. The only thing here is like it doesn't really, it stops short of the last element, but I guess that's something they missed here, but that's okay. Um, let's just check C and D. The code segment iterates through my list, comparing each element to the elements that immediately follows, not just the one that immediately follows. It compares it to all of the subsequent, all of the ones that follow, um, not just the one that follows it. And the last one, comparing each element to the element that immediately precedes. No, it doesn't just check it against the one immediately before it. So the answer here for me is B. Is the one that where it says that segment iterates through my list. Again, my note is just that it doesn't quite go to the last. It stops short of the last element, but that's fine. Comparing each element to the all subsequent elements in the list. And then one more question. I'm sorry that took forever. And this one is okay. So, a student is creating an application that allows customers to order food for delivery from a local restaurant. Which of the following is least likely to be an input provided by the customer using the application? Which of the following is least likely to be an input provided by a customer using the application? Okay, so it's uh, allows customers to order food for delivery from a local restaurant. Okay, the address where the order should be delivered. Well, you need that, so that's not least likely. Um, the cost of the food item currently available for order. I'm pretty sure you need to know the cost. I mean, I wouldn't order something if I didn't know how much it is. These are like least likely, so it can be somewhat subjective. The credit card payment information for the purchaser. Uh, well, you might not need that because you could pay with cash or some other form of payment. And then the name of food item to be included in the delivery. Um, um, so we have a application that allows customers to order food for delivery. So to order food for delivery, which of these is least likely to be an input provided by the customer? Oh, input provided by the customer. Well, the cost. I'm sorry, my mistake, because all of them made sense. Yeah, because the customer would provide the name of the item that they're ordering, the credit card to pay, um, or payment. I'm sorry, yeah, or payment information, whatever it's if it's cash or check or whatever, and the address where it's going. So those three would come from the user. The cost of the food item would be, provided by the restaurant. So the wording is very tricky sometimes. Watch out for it. Even I got confused there. All right, that's all six. Thank you.